Mommy's point blank lesson is really fun.
The lesson is 1.3 today. Our lesson is on least common multiple. Our essential question: how can you find the least common multiple of two whole numbers? Let's unlock the problem. In an experiment, each flower pot will get one seed. If the flower pots are in a package of 6 and the seeds are in a package of 8, what is the least number of plants that can be grown without any seeds or pots left over? First, explain why you cannot buy the same number of packages in each item. Well, the reason is that the items are not sold in packets with equal amounts. The flower pots come in packages of 6 and the seeds come in packages of 8. Now, the least common multiple, or LCM as it's going to be referred to, is the least number that is in common multiple of two or more numbers. One way to figure that out is just to make a list. The first 8 non-zero number multiples of 6 and 8, and then circle the common multiples. Then find the least common multiple. So, for example, multiples of 6 is 6, 12, 18, 24, 30, 36, 42, and 48. What I mean by multiples are, this is what you get in the chain. So 6 times 1 is 6, 6 times 2 is 12, 6 times 3 is 18, 6 times 4 is 24, 6 times 5 is 30, and so on. So they're not numbers that I'm just making up. Now multiples of 8. We have 8, 16, 24, 32, 40, 48, 56, and 64. So now I'm looking to see if they have anything in common. As I look to see what they have in common, so far I don't see anything. I'm trying to match, and there's 48 and 48. Now in this case they only have the one number in common, and it happens to be, and so therefore that is the least number. If they had other numbers that were before this 48, then my least number would be 48. But since they do not, my least common multiple is going to be 48. Another way, we can use prime factorizations and a Venn diagram. So write the prime factorization of each number. So 6 equals 2 times 3, and 8 equals 2 times 2 times 2, just like we did in the factoring tree. So if we did a 6 up here, we'd go 3 times 2. If we did our 8 over here, we would do 4 times 2. Let me scroll my buttons. And then the 4 would break off into 2 times 2. Okay, just like we did in the factoring trees in our lesson yesterday. Now, list the common factors of each number, if any, which we did. And as we're doing that, we see that on this side we have 3 and 2, and over here we have 2 and 2. So the least common that they have is 2 of prime factors, right? So 3 times 2 times 2 times 2 is 24, because 3 times 2 is 6, 6 times 2 is 12, and 12 times 2 is 24. So the least common multiple of this is 24. And so the least number of plants is going to be 24. All right, example. Use prime factorization to find the least common multiple, or LCM, of 12 and 18. Write the prime factorization of each number. So 12 equals, and again, prime factorization, that's when we're doing that factor tree from yesterday, right? Or, in our case, Friday. So we have 2 times 2 times 3. And then for 18, we have 2 times 2 times 3 times 3. And then what they're doing is they're lining up the common factors. So see how we've lined up the common factors here? Whoops. Okay. And then you're going to multiply one number from each column. So 2 times 2 times 3 times 3 is 36. So the least common multiple of 12 and 18 is 36. Now let's find the other multiples. All right, let's do a few more. So we're going to use prime factorization for 10, 15, and 25. So in order to do that, whoops, let me switch my pen here. So 10, again, I'm going to use prime factorization. I've got 2 times 5 is 10. And then if I break apart 15, I have 3 times 5. And if I break apart 25, I get 5 times 5. So when I write this all out, I get 2 times 3 times 5 times 5 times 5, or equals, sorry. So make sure I've got these. I've got my 2 times 3, and I've got my 5 and 5. So equals 150. So my least common multiple is 150. If you're wondering where I got that 150, it's 2 times 3, which is 6, times 3, which is 30, times 5, which is 150. Now let's look at 320, 3 and 10. Let's look at part B. So multiples of 3 are 3, 6, 9, 12, 15. And multiples of 12 are 12, 24, 36, 48. Again, when I'm doing this, I'm going to, when I'm doing the list form, which some of you might like the list over prime factorization, in the list, I simply look to see, and it looks like 12 is the number that's the smallest that they both have in common. So my least common multiple is 12. You can do either way. If prime factorization works for you, great. If you like the list method, great. How can you tell whether the least common multiple of a pair of numbers is the one of the numbers? Let's give an example. So if one number is a multiple of the other, then the lowest common multiple is greater than the number. For example, 27. 27 is a multiple of 9, so the least common multiple of 9 and 27 is 27, which is the greater number. Number 2, explain one reason why you might use prime factorization instead of making a list of multiples to find the least common multiple of 10, 15, and 25. Well, oops, excuse me. Well, you would have to list 15 multiples of 10 to get to the least common multiple of 150. And so using prime factorization will take up less time and less space. Let's share and show. We're going to list the first 6 non-zero multiples of 6 and 9, and then circle the common multiple, and then list the least common multiple. So let's do 6. So 6 times 1 is 6, 6 times 2 is 12, 6 times 3 is 18, 6 times 4 is 24, 6 times 5 is 30, 6 times 6 is 36. And I'll do our multiples of 9. 9 times 1 is 9, 9 times 2 is 18, 9 times 3 is 27, 9 times 4 is 36, 9 times 5 is 45, and 9 times 6 is 54. So let's circle all of the ones we have in common. We have 18, we have 36, and looking at those, the smaller number is 18, so the least common multiple of 6 and 9 is going to be 18. Now I'd like you to do the rest on your own with a partner, or you can join me at the carpet if you need any help. Good luck.